So let's talk about bone marrow, and in this video we'll also talk about how we can build bone up or break bone down and why we do this. But first let's talk about the two different types of marrow. There's red marrow, and it looks sort of thick, like really thick blood. It's called hemopoietic, which produces blood cells. And it's in that sort of bubbly area of the bone that is in flat bones and the epithelial of the long bones. Let me show you a picture. So it's going to be in the spongy area. This is where it's going to go ahead and be in the flat bone, or in the long bone, it's going to be at the ends, right over here. And it's found in vertebrae, ribs, sternum, pelvis, girdle, all these different areas. And this is where we're going to go ahead and make red blood cells and white blood cells, which are the ones that fight off our immune system. Inside long bones, we have a different type of marrow, and it's called yellow marrow. And that's going to be fatty marrow. It's in the long bones. It's stored energy. And if we ever have to make a bunch of red blood cells, we can tap into this to make blood cells really quickly. So it's stored energy just in case you go ahead and bleed out quite a bit and you have to replenish it, or you give blood or something like that. We can actually go ahead and make more. But if we look at bone itself, it's basically just minerals. And minerals, if you let them sit on something with a charge, they'll actually just start to calcify it. So what you're looking at in this little picture below is how they make rock candy. You basically go ahead, take a whole bunch of sugar, put some dye in there, throw a string in there, and let some time sit. And basically what will happen is the sugar will start to crystallize on the string, and that's what you're seeing here. The crystallization is because the ions sort of binding to that area and starting to bind. But now let's kind of equate it back to the bone. What happens is, in bones, we don't have strings that you kind of find in your garage. We have collagen. And these collagen is what makes those minerals sort of deposit itself onto them to give it strength. So that's what's going to give it those collagen mineral fibers that are going to wrap around the bone. And minerals are used for a lot of things. Calcium and phosphate in particular, they're going to be a main thing for DNA, RNA, ATP. That phosphate, that triphosphate, is the phosphates that we're talking about. The calcium is needed for neurons and muscle communication. And when there's not enough, what we do is we go to our reserves, and our reserves are going to be the bones themselves. So let's talk how that happens. So let's talk about levels that we need to go ahead and get some calcium. So there's not enough calcium in the body. There's this thing called the parathyroid, and it's going to be called PTH, parathyroid hormone. And what that's going to do is it's going to go to the bone itself and actually steal some calcium from it through this sort of unique way. So what will happen is the primary hormone that's responsible for this is going to be the PTH. PTH is going to be basically monitoring the levels of calcium in the blood. So now let's go ahead and say that the calcium in the blood is too low. What will happen is we're going to start to go to that parathyroid, and the parathyroid is right around your neck. You know where the thyroid is, and para means behind it. It'll start making its hormone, and this hormone is called PTH, parathyroid hormone, and what its job is to do is increase blood calcium levels. So what it's going to do is it's going to do a couple of steps. Step one, it's going to make osteoclasts. And it's going to break down some bone matrices to release the calcium. So that makes sense. You go ahead and say, hey, we're low on calcium. You get these osteoclasts. Remember that clast means that it's going to break bone down, and it's going to start releasing calcium. So that promotes calcium uptake, and it's even going to go ahead and tell the kidneys that, hey, anytime we have any waste product that is calcium, just put it right back into the blood system. It also promotes this thing called calcitrol, which synthesizes in the kidneys to make sure that we keep as much calcium as we can get. And it inhibits collagen synthesis. Why would this happen? Remember how we said in that picture there was that string and then all the sugar was sort of like growing on it? Pretend that's sugar. Basically, why inhibiting the collagen, what we're going to do is we're going to prevent that from ever growing. So the calcium is going to be more bonded to the blood than the bone. So if we want to do the opposite, what we're going to do is promote collagen synthesis, and now what will happen is the minerals will start to come on the collagen and sort of land, so we can reverse that process. So PTH, which is parathyroid hormone, is basically a negative feedback process that we don't see enough calcium in the bone. We're going to go ahead and activate it at the bone level. And if we keep going, you'll see that what happens is we see that there's an imbalance in calcium levels. We're going to go to the back end of that thyroid. So this is going to be the back, so parathyroid. You can see these little glands over here. And what will happen is that is going to stimulate a hormone called parathyroid hormone. It'll increase in numbers, and that's going to stimulate these osteoclasts to release calcium. And that'll get that calcium level back to normal levels. And anywhere from 9 to 11 milligrams is what most adults have. When it gets imbalanced, we're going to activate this system. But now let's go ahead and say now we have too much calcium in the blood. What do? We activate another hormone called calcitrol. And what that is going to do, it behaves like a hormone. It works with the parathyroid hormone, and basically what it's going to do is it's raise the blood calcium levels. It stimulates calcium from the diet. It's also going to go ahead and make sure that we get more calcium inside. But let me continue on. Calcitronin, which is what I was hoping to talk about next, is a hormone that's secreted by the thyroid gland. So this is the thyroid. This is that thing that men have a little more predominant cartilage here. It's called the Adam's apple. And behind it is the parathyroids, these little yellow things. So the thyroid itself is going to regulate calcium levels, and if they get too high, it's going to go ahead and do this system, which is calcitronin. And it's a hormone secreted by the thyroid gland. Calcium levels are too high, so what's going to happen is it's going to make it so that osteoclast activity gets less, and there's going to be less bone breaking. It's going to stimulate osteoblast activity, and then the other thing it's going to do is collagen is going to start to increase. So when the collagen increases on the bones, it'll give it areas for the mineralization to occur. In our next video, we'll talk about how bones are formed.